So we're looking at Newton's law of universal gravitation. Let's say we start with the classic apple on the head version of Newton's work. He started with the idea that since the Earth is pulling on the apple must also be pulling on the Earth. And we talked about this last time. Ask a person on the street where gravity comes from, and they'd say the Earth. They would never consider the apple as another source of gravity. But if the apple is pulling on the Earth, that means that an object doesn't have to be huge to have a gravitational pull on other objects. There is nothing special about the Earth compared to the apple. Both are sources of gravity. That would mean that one apple should be able to have a gravitational pull on another apple. That means that any mass pulls on any other mass. The reason we don't see the effect of you being pulled towards your cell phone or your table partner is that the masses are so small that the force is also small. But the force is there, and Newton wanted to come up with a way to calculate it. So, using lots of calculus and some tough physics, he came up with two key concepts. The force of gravity between two objects is proportional to the two masses. Okay, as long as one of the masses is big enough, like the Earth, then the force becomes noticeable. So we say force of gravity is proportional to m1, m2, the two masses. The force due to gravity is inversely proportional to the square of the distance between the masses. The distance is measured from the center of the two objects. We talked a little bit about this last video. So we usually consider it to be radius. As the distance increases, the force drops off exponentially because it's to the squared. Okay, and you're going to see that in activity you do as well. So I'm going to go through and do this first example. Okay, the force due to gravity between two objects is 160 newtons. Okay, determine the magnitude of the magnitude of the force if one of the masses is doubled. That's what we're going to do first, and then we'll worry about the second part. Okay, so remember the force of gravity is directly proportional to mass 1, mass 2. So this isn't a formula, we just learned that he said they were proportional. So all of a sudden, we have doubled one of the masses. Okay, so instead of just being mass 1, we have twice as much. Well, mathematically, if you do something to one side, guess what? You have to do it to the other side. So now the force is also doubled. We started with 160, now we have two 160s, so that's going to be 320 newtons. Okay, let's look at B. The radius is doubled. Well, we said that FG is proportional to 1 over r squared. Okay, now we have the radius doubled. So what we have done is we have taken r, and instead of r, we actually have 2r, but it's all squared. Well, what happens when you have 2r and you square it? FG is going to be proportional to 1 over 4r squared. So remember, we started with 1 over r squared. So we've really taken 1/4. We've actually divided it by 4. What we do to one side, we have to do to the other. So if you double the radius, the force is 1/4 of the amount. Okay, so we had 160. Now we need to divide that by 4. Well, 16 divided by 4 is 4. So we're left with 40 newtons. Okay, so just to see that relationship of what happens if we do it to one side and the other.